Right now, you're blinking without even thinking about it. Somewhere around every 4 seconds, your eyelids sweep down and back up in about a tenth of a second, so fast that your brain doesn't even register the momentary blackout. You've probably blinked several times just reading this sentence. Now imagine that stopped completely. Not slower, not less frequent, gone. Your eyes stay open, permanently, unable to close. You might assume the main problem would just be dryness, mildly uncomfortable, maybe a bit irritating. But that assumption dramatically underestimates what blinking actually does. To understand why, we need to look at what a blink really is. A blink isn't just your eyelids closing. Each time your eyelids sweep down, they do three things at once. They spread a thin layer of fluid across the surface of your eye, they push debris and dust toward the corners for removal, and they briefly shut off light and movement so your visual system can, essentially, do quiet maintenance. That fluid layer is the key to everything that follows. It's called the tear film, and despite the name, it isn't just water. It's built from three distinct layers, each doing a different job. An oily outer layer produced by glands along your eyelid edges slows evaporation. A watery middle layer carries oxygen, nutrients, and antibodies. And a thin mucus layer underneath helps the whole film stick evenly to the surface of your eye instead of beating up and rolling off. Every blink resets this three-layer film. Without blinking, none of that happens. So what happens first? Within seconds, the exposed surface of your eye, the cornea, starts drying out. And the cornea is not like ordinary skin. It has no blood vessels running through it at all. That's actually essential for vision. Blood vessels would scatter light and blur everything you see. Instead, the cornea gets its oxygen a different way, partly absorbed directly from the air and partly delivered by that tear film sweeping across it with every blink. Stop blinking, and you cut off part of the cornea's oxygen supply at the exact same moment its protective fluid layer starts evaporating. This is where the situation escalates quickly. As the tear film breaks down, the surface of the cornea begins to dry unevenly. Dry patches don't just feel uncomfortable, they distort your vision because your eye depends on a perfectly smooth, evenly wet surface to focus light correctly. This is actually why your vision sometimes looks briefly blurry right before a blink and sharp again right after. You're watching the tear film thin out and reset in real time. Now stretch that thinning out indefinitely. Within roughly 20 to 30 seconds of forced open exposure, something doctors can actually observe in patients unable to blink normally, the surface starts to show visible dry spots. The cornea's outer layer of cells, no longer protected, begins to break down. This condition already exists in medicine. It's called exposure keratopathy, and it shows up in people whose eyelids can't fully close, from nerve damage such as Bell's palsy, from certain thyroid conditions that push the eyes forward, or from patients who are sedated in intensive care with their blink reflex temporarily suppressed. Doctors treat it constantly, precisely because it's dangerous. So what actually goes wrong? Without the tear film's antibodies and protective proteins, the cornea's defenses against bacteria and debris weaken. Dust, tiny particles, and microorganisms that would normally be swept away with every blink instead stay in constant contact with an already damaged surface. That combination, a drying, oxygen-starved cornea with reduced defenses, creates ideal conditions for corneal ulcers, open sores on the eye's surface. And because the cornea has no blood vessels to rapidly deliver immune cells for repair, it heals far more slowly than almost anywhere else on your body. Left untreated, corneal ulcers can scar, and corneal scarring is a leading cause of preventable blindness worldwide. Not because the eye itself stops working, but because the clear window your eye needs to focus, light has become permanently clouded. This reveals something important about the eye you don't usually think about. Your vision doesn't just depend on your retina detecting light or your brain interpreting it. It depends on a perfectly maintained, transparent surface layer that has to be actively rebuilt roughly every few seconds for your entire life without you ever noticing. But there's a second problem running in parallel with the drying itself. Blinking doesn't just refresh moisture, it also clears debris. Every few seconds, your eyelids sweep dust, pollen, and microscopic particles toward your tear ducts where they drain away. Without blinking, none of that gets removed. Particles accumulate directly on an increasingly vulnerable surface, adding mechanical irritation to a cornea that's already losing its protective coating. You might expect your eyes would simply water more to compensate, and in mild dryness, they sometimes do. Irritation can trigger reflex tearing. But reflex tears are a different, more diluted fluid than the balanced three-layer tear film a blink normally spreads. They don't fully replace what's missing, and they can't substitute for the mechanical sweeping action that removes debris and evenly redistributes the film in the first place. So even with excess tearing, the eye keeps deteriorating. Now here's where the thought experiment forces us to confront something else. Could you consciously override this and simply never blink again? In practice, no. And the reason reveals something about how deeply blinking is wired into the nervous system. Blinking isn't a habit you learned. It's a protective reflex, triggered automatically by sensors in the cornea itself, coordinated by a part of the brainstem, largely outside conscious control. The moment your eye's surface becomes irritated enough, which, under this scenario, would happen almost immediately, your nervous system would fight to force a blink regardless of what you intended. This is the same reflex that makes you blink automatically when something flies toward your face, before you've even consciously registered the threat. So a genuinely permanent stop to blinking wouldn't just require willpower. It would require either disabling that brainstem reflex circuit or physically preventing your eyelids from closing. Conditions that, again, do occur in real medical cases, which is exactly how doctors know what happens next with such consistency. In those documented cases when eyes can't close and blinking can't occur, doctors intervene immediately. Lubricating drops, ointments, moisture chambers, sometimes temporarily taping the eyelids shut, precisely to prevent exactly the sequence of damage we've just walked through. Left uncorrected, that same sequence, drying, oxygen deprivation, breakdown of the surface, infection risk, scarring, can progress to permanent vision loss within days, not years. Days. That's the part that tends to surprise people. Something as routine and invisible as blinking is protecting your vision on a timescale far shorter than most people would guess. Not decades of gradual wear, but a process that could seriously threaten your eyesight within about a week if it stopped entirely. Which brings us to the bigger picture this scenario actually reveals. Your body runs an enormous number of automatic maintenance systems you never consciously notice. Your heart adjusting its rhythm, your gut lining replacing itself every few days, your skin constantly regenerating. Blinking belongs in that same category. A quiet, continuous repair cycle running in the background of your life, occurring roughly 15,000 to 20,000 times a day without a single moment of your attention. We tend to only notice systems like this when they fail. A working cornea is invisible. A damaged one is not. So if you stopped blinking forever, the ending wouldn't be gradual irritation you slowly adapt to. It would be a fast, escalating breakdown of one of the most precisely engineered surfaces in the human body. A surface so thin, so clear, and so quietly maintained that it's easy to forget it needs maintaining at all. And that's really the answer hiding inside the question. The parts of your body working hardest to keep you functioning are often the ones you notice least, right up until the moment they stop. If this kind of question got you thinking, subscribe to Curioscope for more deep dives into the science hiding inside everyday questions.